So in this video, I'll be continuing with the 3E Pure Physics end of year 2019 paper. So this is question 14. So question 14 is about, I think, forces, moment, and kinematic. So first of all, what I would always do when I'm faced with this kind of question is that I would want to have all the numbers presented on the same diagram so that I can refer to it easily. So first of all, you know that the pushing force is 600 Newton. So this is 600 N. The box would have a mass of 100 kg, and I would always pay very close attention to the mass because sometimes the setter can be evil and they give you in gram and you got it wrong if you use grams, okay? And they are saying that this box will accelerate towards the left at 0.8 meter per second square. I also want to check whether the question mentions smooth surface and none. And I can see that in part 1, I'm supposed to find frictional force, meaning that there's another force over here. That is F. And basically, I'm only interested in the forces that's acting on the box. So some of you may be asking me, teacher, how come you never draw, why you never draw the weight and the normal contact force? Well, because I can see that the question is interested in the horizontal dimensions. So because of that, I will only analyze my horizontal forces the forces in the horizontal dimension. Okay, so let's take a look at what the students say. Very good. This is an excellent habit, writing down the starting formula. F net equals to MA. She changed F net into sum of forces, which is 600 plus negative F. So she skipped a step, but it is fine. And I can see that she picked the correct sign convention because the acceleration is to the left, right? So it means that I should have F net that is going to the left as positive, and as a result, friction is negative. Good. Good. Mass is in 100 kg. A is 0.80. The math is correct. Math is correct. So everything is correct. This is correct, but unfortunately this is wrong. This is 1 SF. So actually you should keep it to 2 SF. This is 2 SF. Yeah. So you will still get 3 marks, but overall you will get penalized. Overall, as the paper overall will get penalized. Okay, for part 2, you need 2 methods to reduce the frictional force acting on the box. Well, adding lubricant is 1. Having an air cushion between the floor and box is 1 as well. Adding wheels. There are many things you can do as long as it is a sensible one. Okay, reducing the surface area, no, it doesn't work. Polishing the floor, yeah, you reduce the surface roughness. So use a box that is with a smooth surfaces, yeah, can, no issue. Okay, now in part B, it becomes a moment question. How do I know that it is a moment question? Well, I see the word pivot. I know that it is moment. Yeah. So basically the diagram has included almost all the forces that you need. You have 3 players here, P, N, and W. So there are 3 forces there. And why is friction not there? Okay, I'm not sure why friction is not there, but even if friction is here, well, since the pivot is at this corner, there's no perpendicular distance between friction and pivot, so I think that's why friction is not included. So anyway, explain why N does not produce any moment on the box. N is on the same line of action as the pivot. Yeah, you got everything correct, but the phrasing wrong. So you should say that the pivot is a point, you see. So a point can be on the line. You won't say like this line is on this point, right? You will say this point is on this line, right? So you should say that the pivot is on the line of action of n. Well, that is good enough. But if it is a 2-mark question, then maybe you would want to code that by m equals to f times d, d will be equals to 0, and therefore m is 0. Okay, so you may want to add just one line to talk about it. But for a 1-mark question, you can just tell me that the pivot is on the line of action of n. And you need to pay attention to the phrasing. Okay, you can't say a line is on a dot, right? Pivot is a dot. You can say that the dot is on a line, and this line comes from n. It's a property of n. So you need to know the correct way to structure your answer. You cannot just lump all the science vocab together and then like fried rice and then it's fried rice. Cannot. Physics is fine dining. There is a course given to you, right? Appetizer, main course, dessert. That is the way to eat. You cannot give dessert, appetizer, main course. No, it doesn't work that way. Okay? Physics is fine dining. It is not fried rice. Okay? Although fried rice tastes good lah, but it's less elegant, you see. Okay, in your part 2, you are supposed to give me find the P, right? So you need to tell me, very important, that you are taking moment. You must have this statement. If not, we will penalize you. Okay, about the pivot. So you want to say clockwise. It's not CWM, sum of CWM and sum of ACWM. So let's take a look at this. So clearly you can see that there is P and then there's a pivot here. So this P will actually create a moment that is this way. So this will give me anti-clockwise 1. And you have the weight over here. That means this force will create a moment this way, which is CW1. Okay, so CW is caused by weight. Okay, let's see here. CW is caused by the weight. So the mass is 100 kg. And so the weight is 100 times 10, right? And it is on the correct side, the clockwise side. Distance, very good, 0.8. It will be equal to the anti-clockwise moment, which is given by the unknown force P, which is 1.2 meter away from the pivot. So very good. If she did her math properly, this would be the answer. And you got yourself 3 marks, right? Finally, one method to improve stability. Very good. Increase the base area of the box. Or you can say you would want to lower the position of the CG. Like I said, remember, fine dining. Physics is fine dining, okay?